So what is infrastructure as code? Sir, infrastructure as code is the management and provisioning of infrastructure through code. Instead of using manual processes and settings, we can provision and manage our infrastructure with the help of code, and that term is known as infrastructure as code. We write the code files to provision our infrastructure, and we can run those files via any infrastructure provisioning tool like Terraform to build, manage, and provision our infrastructure on all the cloud platforms. Alright. In addition to that, infrastructure as code also automates the process of infrastructure provisioning. Infrastructure as code also helps organization to develop, deploy, and scale all the cloud applications. So the shortest definition of infrastructure as code is to codify your infrastructure. Terraform is one of the best and leading infrastructure as code tool. Hey guys, we have started with Terraform, and in this phase we are going to cover the basics of all Terraform interview questions and answers. So this is actually question number 2, and it is about Terraform. What is Terraform? Terraform is an infrastructure as code tool which allows us to configure and deploy our infrastructure on the cloud. So in other words, we can say that Terraform is an infrastructure as code tool which helps us to build, change, deploy, and version our infrastructure resources over the cloud. And by cloud, I mean to say AWS, Azure, or Google Cloud Platform. We can also provision infrastructure using Terraform on our on-prem data centers as well. Terraform configuration files have the extension as .tf, like main.tf, provider.tf, variables.tf, and those configuration files are written in HCL, which means HashiCorp Configuration Language. And it is a declarative coding language which describes the state of our infrastructure. So Terraform is a must tool for DevOps engineers, and as a DevOps engineer you can expect a lot of interview questions and answers from Terraform. And don't worry, I got your back. We are going to cover a lot of interview questions and answers of Terraform. Stay tuned. What is a Terraform state file? The Terraform state file is a JSON or a binary file that stores the current state of our managed infrastructure. Terraform state file is really an important file because it records the resource metadata, dependencies, and other relevant information. The Terraform state file is critical for all the Terraform operations as it allows Terraform to understand the existing infrastructure, and it also tracks changes over time. So I would say that without a Terraform state file, we cannot manage our infrastructure using Terraform. And Terraform state file is created when we run Terraform apply command. So what is the purpose of Terraform plan command? So Terraform plan command is one of the most frequently used Terraform commands. The Terraform plan commands provides us a summary of all the actions that Terraform will take, such as creating, modifying, or deleting resources. So we can also say that Terraform plan gives us an overview of the infrastructure that is going to be provisioned. Terraform plan prints the output in the JSON format, and it is really easy to go through the whole output and review the changes. So we can say that Terraform plan allows us to review and verify the changes before applying them to the infrastructure. And I'm pretty sure that as a DevOps engineer, we use this command a lot. Alright, what are Terraform variables? So Terraform variables allow us to parameterize our infrastructure code and make it more reusable and more configurable. How can you use Terraform variables in your infrastructure code? Variables can be used in the Terraform configuration files or in separate variables configuration file. We can also configure variables to customize resource configuration, such as specifying the number of instances or setting environment specific values. Okay, there are different types of variables used in Terraform like number, string, bool, list, and map. For instance, if I have to provision a virtual machine, then I can declare a couple of variables like AMI, instance type, tags, subnet ID, resource group. So we can declare these variables in variables.tf, and we can give the values of these variables in terraform.tf vars file. And finally, we can call all those variables in our main.tf configuration file. So that's how actually variables work in Terraform. Perfect. What is a Terraform backend? So the Terraform backend is a configuration option that stores and manages the state of the Terraform infrastructure in a local or a remote location. Terraform backend is responsible for storing state files. Terraform backends also provide an API for locking the state files. Terraform backends are also responsible to determine how the state data is loaded and updated. Okay. One of the major advantages of Terraform backends is Terraform backends allow multiple teams to collaborate and synchronize state files. So when we run Terraform, Terraform checks the backend for state file changes and finally applies those changes to the infrastructure. So what are the types of backends? So basically there are two types of Terraform backends: local backend and a remote backend. So would you like to share the difference between a local and a remote backend? I was expecting this question. Okay, so the difference between local and a remote backend is quite simple and straightforward. Local backend is a Terraform backend where the state file is stored on local system. When we are using the local backend, then the Terraform will store our state file on our local machine. Whereas in the remote backend, the Terraform will store the state file on a remote location, and that remote location can be an S3 storage bucket or Azure blob container or Google Cloud Platform storage bucket. So we can use remote backends to store our state files on a remote location. And most of the time, IT companies use remote backends so that their teams can collaborate and synchronize the state files. I want to create a custom local backend. How can I configure a custom local backend for our state file? So by default, when we are using the local backend, Terraform will store the state file on that location where we are running Terraform init or Terraform plan commands. But if we want to have a custom local backend, then we can add the workspace directory and the path where we want to store our state file. I'm sharing this code where we can see that we have a workspace directory and a path, which is a custom local backend to store our state file. So what are the benefits of using remote Terraform backends? So remote backends help multiple teams to collaborate because the Terraform state files are stored on a single remote location. So multiple DevOps engineers or developers can coordinate with each other to modify or provision infrastructure using those state files that are stored in a remote location. So we can say that remote backends provide better scalability, collaboration, support, durability, and synchronization, helping developers and DevOps engineers to manage their infrastructure at scale in a production environment. So if I'm using a local backend, it means that only I can modify or provision the infrastructure, and none of my team members can work on those Terraform configuration or change the state files. But when we have a remote backend, it means that we are storing our state file on a remote location like Amazon S3 or Azure blob container or GCP storage bucket, and every member of my team can work on those state files and provision the infrastructure accordingly. So that's why remote backend are really important when we are managing our infrastructure in production environment. Okay, so for example, if I want to configure a remote backend on Azure, what would be the prerequisites for that? So if I want to configure a Terraform remote backend on Azure, I would need three major resources. Number one, a resource group on Azure. Number two, a storage account. And number three, a blob container. Okay, I would need a resource group because in that resource group, I will create a storage account. And when I have a storage account, I would be able to create a blob container. And actually, the blob container is the storage point where our Terraform state files are stored. So I should have a resource group, a storage account, and a blob container where our Terraform state files are stored. So that's how we can have a remote backend on Azure. Got it. Hey guys, I hope you're doing great today. Do you know about a provider in Terraform? So as a DevOps beginner or a fresher, you can expect what is a provider in Terraform. And this is one of the basic questions of Terraform. A provider in Terraform is a plugin that enables interaction with an API. And that API actually helps Terraform to provision infrastructure on that cloud platform. So if I'm going to provision my infrastructure on AWS, then it is obvious that I would have to use AWS as provider, and Terraform will build the infrastructure on our AWS cloud platform. And that provider actually has the APIs that help us to build the infrastructure. So all those APIs are combined into a plugin, which is a provider. Therefore, it is must to specify a provider in our Terraform configuration files. If I am building my infrastructure on Azure, then Azure M would be the provider. So each cloud platform has their own provider, and we can have the more information about each provider on the Terraform registry. So what is a Terraform module? A Terraform module is a set of Terraform configuration files in a single directory. A single directory with one .tf configuration file is known as a module. Terraform modules are used to improve organization, create reusable components, and treat infrastructure as a black box. So the shortest definition of a Terraform module is the collection of .tf files in a directory is a Terraform module. Okay, what is tainting in Terraform? So tainting in Terraform is a process that marks a resource as damaged or degraded. So after marking any resource as degraded, Terraform schedules its destruction, and also Terraform recreates this resource. So in our Terraform workflow, if Terraform finds any resource which is damaged or degraded, Terraform marks it and schedules it for destruction. It means that Terraform will first destroy it, and then it will recreate that resource. Terraform also ensures that resource is recreated from scratch. So that process is known as Terraform tainting. Alright guys, you know about Terraform tainting. Terraform tainting is a process to find the damaged resource and recreate it from scratch. But there is also another term which is known as Terraform untainting. So there are basically two commands, Terraform taint and Terraform untaint. So what's the difference? The shortest difference between Terraform taint and untaint is Terraform taint marks the object as damaged, and Terraform untaint removes that object from tainted status. Terraform taint marks the resource as tainted, means damaged or destructive, and Terraform also suggests to replace any damaged resource or object. So when the object is replaced, we can use Terraform untaint, and it will just remove the state of tainted from any object. What is the difference between Terraform destroy and Terraform taint? So Terraform taint marks any object as damaged, and that damaged object is replaced with a new object. But Terraform destroy the resource or object, and that object cannot be replaced. Terraform taint replaces the damaged object, whereas Terraform destroy destroys the object completely. You're late. My apologies, sir. I got stuck in the traffic. No problems. Sometimes it happens. Anyways, without any further ado, how would you manage the secrets and passwords in Terraform? So Terraform config files and state files become vulnerable if they contain secrets and passwords in plain text. Alright. And we must avoid it at any cost. So we have a couple of ways to manage secrets in Terraform. We can use environment variables to store secret values. We can use the Terraform's built-in capability to mask the values of any resource or variable. We can use input variables to store secrets and then reference them in the configuration files. We can use third-party vault and secret manager applications to fetch the secrets from these external resources at runtime. Okay, so these are a couple of methods in which we can protect our sensitive information in Terraform. In Terraform, there is a file terraform.tfstate.backup. What's that file used for? Yes, sir, there is a file that is created and is known as terraform.tfstate.backup file. And in simple words, it is the backup of terraform.tfstate file. We know that when we run Terraform apply command and after our infrastructure is provisioned, a terraform.tf state is created. But the beautiful thing is that Terraform also creates a backup of the terraform.tf state file at the same time. And that file is known as terraform.tfstate.backup file. So actually it is the backup of terraform.tf state file. And the core purpose of terraform.tfstate.backup file is to ensure that we can recover from a corrupted or lost state file. So where there is a Terraform state file, there should be a Terraform state backup file. What are the use cases of backup state file? I mean, in which cases we can use this Terraform backup state file? So there are many use cases in which we can use the Terraform backup state file, but I would like to highlight the showstopper, which are three. So I mean to say that if we are facing these three issues, we can use the Terraform backup state file. Number one, if we have lost Terraform state file accidentally or that file is corrupted. Number two, if we accidentally remove a resource from the Terraform state management. And number three, and the most frequently used use case of backup state file is we can revert to the previous version of the infrastructure using backup Terraform state file. So these are the three major use cases of backup state file. So what is state locking in Terraform? Sir, in state locking, Terraform will log our state for all the operations that could write the state. Okay. State locking prevents other users to acquire the lock and potentially corrupting the state. It means that only one person can modify the Terraform state at one time. For instance, if we have a team of 10 DevOps engineers, so it does not mean that all those engineers should modify the Terraform state file at one time. And that is why Terraform locking helps, and the state is locked to only one DevOps engineer at one time. And when that Terraform state is locked, no other DevOps engineer from the DevOps team would be able to modify the Terraform state. So Terraform state is one of the best features of Terraform, and it prevents state corruption and avoids the conflicts. Great. How state locking works in Terraform? So when I run Terraform apply or Terraform refresh, Terraform will lock the state file. And if I talk about behind the scenes, Terraform will create a log file according to the backend we have configured. The backend can be Azure Blob Container or AWS S3 storage bucket. And actually that log file that is created by Terraform indicates that the state is in use. So no other user would be able to modify the state. It is just as simple as we lock the door of our room so that nobody can enter into the room and the access to that room is blocked for all the users. So state locking also works the same way. When the state is locked, access to the state is denied for all the users. And Terraform uses that log file for log acquisition. And once the operation is complete, I mean when the Terraform apply is complete, Terraform releases the lock. So that's how state locking works in Terraform. And it is really important when we are working as a team and provisioning infrastructure using Terraform. Okay. Hey guys, I hope you're doing great today. In the previous videos, I have shared what is state locking and how state locking works in Terraform. But what if I told you that it is possible to unlock a Terraform state forcefully? And yes, it is possible. We can use the force unlock Terraform command to manually unlock a Terraform state that has been locked by another process. So the Terraform force unlock command will forcefully remove the lock on the state for the current configuration. So if a user in my team has acquired the Terraform state, I can forcefully remove him using the force unlock Terraform command. And the good news is it will not modify our infrastructure. What is a Terraform log file? Would you mind to explain it in detail? So the Terraform log file is a hidden file and it is named as .terraform.log.hcl. Okay. Terraform log file is a file that tracks the versions of the provider plugins and modules used in a Terraform configuration. Terraform log file is created when we run Terraform init command, and the log file is also created in the same configuration directory of Terraform. And in simple words, Terraform log file takes the snapshot of all the provider versions or module versions we are using in our Terraform configuration. And the Terraform log file ensures that the same provider provider versions are used in all Terraform operations. So this is actually the core purpose of the Terraform log file. And it's really important to have our Terraform log file, terraform.log.hcl, into our version control system so that our team members should use the same provider configurations. Alright, so I have a simple and basic question for you. How can you assure that all your Terraform configuration files do not have any syntax issues? Can you confirm it real quick? If we have tons of Terraform configuration files, and checking each configuration file for syntax issues can be a big overhead. Luckily, Terraform resolves this problem real quick with the help of Terraform validate command. So Terraform validate command examines each configuration file for syntax issues regardless of the variables or current state. So Terraform validate command actually verifies the correctness of all Terraform configuration files in one go. Not only Terraform validate checks for the syntax issues in our Terraform configuration files, but it also ensures the correct usage of attributes and values. So I would strongly recommend that we should run Terraform validate command before running Terraform apply or plan, as Terraform validate will help us to get a valid configuration that actually works. What are the most useful Terraform commands? Please explain the usage briefly. Sir, as far as most useful Terraform commands are concerned, I would say that these commands are the toppers. Number 1, Terraform init. It initializes the current directory. Number 2, Terraform refresh. It refreshes the state file. Number 3, Terraform output. It is used to view the Terraform outputs. Number 4, Terraform apply. This command is actually used to build the infrastructure using the Terraform configuration files. And number 5, Terraform destroy. It is a dangerous command and it is used to destroy the infrastructure provisioned by Terraform. Number 6, Terraform graph. It creates a dot formatted graph to show the resource dependencies. And number 7 is Terraform plan command, and it's a dry run to see what Terraform will build for us. Number 8, Terraform FMT. It rewrites the configuration files to a proper format. And number 9, Terraform validate command, and it checks Terraform configuration files for syntax issues or errors. So I would say that these 9 commands are most useful Terraform commands. What is a workspace in Terraform? Would you like to explain it in detail? Sir, a workspace in Terraform is a feature which allows us to manage multiple environments within a Terraform configuration. We can manage multiple environments using Terraform workspaces. We can use workspaces to create multiple instances of the same infrastructure in different environments like dev, staging, QA, or prod. Okay. With the help of Terraform workspaces, each environment will have its own set of variables, resources, and state files. We can also reuse the configuration for each environment. We can also use Terraform workspaces to deploy our resources on dev or staging environments before we push them to prod environment. Therefore, it is a recommended practice to create Terraform workspaces for dev, staging, QA, or prod environments. And we can use Terraform workspace command to create a workspace in Terraform. Gotcha. Have you ever heard about a provisioner in Terraform? Yes, sir, I know about a provisioner. Okay, so what is a provisioner? So a provisioner in Terraform is a tool that executes scripts or commands on a local or a remote machine during the process of resource creation or destruction. We can use provisioners for a number of tasks. For instance, bootstrapping a resource, cleaning up a resource before destroying it, or running configuration management. There are ideally 3 types of provisioners in Terraform. Number 1, file, and it is used for copying files. Number 2, local exec, and it is used for local operations. And number 3, remote exec, which is used for remote operations. Hey guys, I hope you're doing great today. This is question number 26 of our Terraform interview questions and answers series. And I want to ask you that, have you ever heard about destroy timeouts in Terraform? If you don't know the answer, let me explain it. The destroy timeout attribute in Terraform is used to control the destruction time limit for a resource when we run the Terraform destroy command. It may happen with you as well. Sometimes Terraform destroy takes a lot of time. So therefore, by specifying a value which is known as destroy timeout while running Terraform destroy command, we can set a maximum time duration for Terraform before forcefully destroying the resource if that resource takes longer than expected. So if any of your resource is taking much time while you run Terraform destroy command, you can set the maximum time limit using that attribute known as destroy timeout while running the Terraform destroy command. And if that resource is not deleted within that time frame, then Terraform will forcefully destroy it. Would you mind sharing a couple of advantages of using Terraform modules? So Terraform modules can have a number of advantages, and I would like to share the showstoppers. Number one, organization. Terraform modules help us organize configuration into logical components, making it easier for us to update, navigate, and understand the Terraform configurations. Alright. And number two, reusability. We can reuse Terraform modules across different projects. And we can also use Terraform modules across different environments and teams. And this practice will definitely save us a lot of time. Number three, modularity. We can use Terraform modules to break our infrastructure into small chunks, which are modules, so that the DevOps and development teams have a clear idea of the infrastructure running. If I want to say it in more simple words, Terraform modules help to quickly understand the overall infrastructure. And the number four and the most important advantage of using Terraform modules is reducing human errors. Since we can reuse Terraform modules in our different environments or projects, so we are going to reuse the working Terraform configuration across multiple projects or environments. And it will definitely reduce human errors. So these are the major advantages of Terraform modules, and they are extensively used in every IT infrastructure organization who are provisioning their infrastructure using Terraform. Perfect. Hey guys, I hope you're doing great today. We have completed the first phase of Git, interview questions and answers. And those were all basic questions with their answers to clear your Git concepts. I have also created a Git course on my YouTube channel, and you can find the link course in the description of this video. Now I will see you in our Terraform interview questions and answers series. Make sure to follow me on TikTok and subscribe my YouTube channel DevOps Molvi. I will see you in the next video.